Hello, everyone, and welcome to week 8. Today I'll be presenting my bike sharing information system on behalf of Healthy Lifestyle Advocacy Group and explaining the steps taken, the rationale behind my solution, and the steps that remain to be taken to complete this information system. First, let's begin with a system overview. The proposed bike sharing information system is designed to aid daily commuters and tourists. Although there are multiple forms of available transportation, the need to live a healthier lifestyle is gaining popularity, thus the need for this information system. The main processes of this IS will be bicycle renting, user management, and billing. Riders will choose a docking station location for checkout, register either online or at a station, and then a billing process to complete the transaction. The system's architecture will consist of a centralized model, meaning that there will be a central location for management of servers that all outlying docking stations will connect to. With a combination of software, hardware, and databases, it will all come together with ease of management and an intuitive user experience. Now let's dig into some of the hardware and software components. Required software will be the bike sharing application, Microsoft SQL Server, and a front-end website running IIS. All three applications will be loaded on a Windows Server virtual machine. To be included, configuration of the built-in Windows firewalls will be used as endpoint security. For the hardware, a hyper-converged solution will be leveraged. This is an all-in-one package that contains VMware hosts, storage, switching, and all necessary cabling. To be more specific, the required hardware components will consist of one server rack, 4 rack-mounted virtual server hosts, one Windows workstation per docking station, one virtual machine for the web server, one VM for the SQL database, and a 20 terabyte storage array. Also, will include 2 fabric interconnect switches, 2 physical firewalls, a tapeless backup system, 1 network switch, 1 VPN concentrator, and the docking stations themselves. Each docking station will have a PC, a touchscreen, card reader, VPN client, wireless air card, and solar panels. The solar panels will be tied into a bank of batteries and used as emergency power. My reasoning for going with a hyper-converged solution is that it is portable, scalable, turnkey ready, and ease of management for local IT staff. Moving into security. To protect the bike sharing system, certain security practices and devices need to be implemented. The centralized servers will have an internal and external firewall creating a DMZ. This will create a location for the web server to reside and protect internal assets from the outside world. The docking stations will have a metal casing protecting the PC from physical theft, damage, and vandalism. Although each docking station will use a wireless air card for communication, not much can be done to protect against signal interference. The connection from docking station to central servers will be over a VPN, so the data itself will be encapsulated. With the end user in mind, they will have no regard to either system or physical security, so measures must be taken to ensure the protection of the information system from a logical and physical perspective. Applying the latest patches on the Windows systems and keeping applications up to date will further help the safeguarding of this system. There are many steps required to implement this bike sharing information system, and let's run through those steps. Step 1. Identify the location to place docking stations. This will be accomplished from studying public data such as taxi history and requesting users for suggestion via social media. Compiling this data will ensure that docking stations are properly placed within the city to maximize use and profit. Once all the docking station locations have been identified, it's time to start procuring and building out the information system. So step 2, build out the hyper-converged server environment. This includes racking hardware, loading the ESXi hosts, and configuring them. Vendor installment and support will be part of the installation. This gives opportunity for the local staff to ask questions and get familiar with the environment. Step 3, install and configure VPN router. The VPN will allow for secure communication between servers and docking stations. Step 4, deploy virtual machines for the SQL, web server, and bike sharing software. Included in this step is the configuration of the software respective to each VM. For the configuration piece, vendor support is also authorized for questions and familiarity. Step 5, stand up docking stations. This step includes the assembly of the docking station itself to include the solar panels. Once all the physical hardware is in place, installers can move on to step 6. So step 6, Configuration of the PC, card reader, and GPS trackers will take place. Staff will validate the communication that communication has been established between station and central servers. Bicycles will be installed with corresponding GPS trackers. This is to be done at each station. Step 7, and the most important step, which is testing. Once all servers and bike stations are communicating, extensive testing will need to be conducted. Components to be tested will be the billing, website registration, check-in and check-out, GPS tracking, physical tampering, and guest trial runs. During the testing phase, feedback will be paramount for both local staff and guests on the trial runs. If at any point there is an issue, that feedback will be leveraged to correct the problem. There are many bike sharing programs in use, so fixing the issue and moving forward is the only solution. For software issues, IT staff will leverage vendor support. Healthy Lifestyle Advocacy Group has done its due diligence to ensure the implementation goes as smooth as possible. We hope you are completely satisfied with the proposal and hope to put this plan into action as soon as possible. Thank you for your time.